that we are going to get different kind of results, and we can interpret it that based on what are the values. Sometimes it is blurring, sometimes it is sharpening. And look, blurring also have a very important difference. So what do we mean by blurring? So a few minutes back, when we were actually writing zeros, and we understood about 1. So essentially what it means that I told you that you blur your eyes, you will be able to see that 1. I was writing 0, but I told you that if you blur your eyes, then you will be able to see the 1. So blurring means what? That you are actually filtering out the low frequency components. You are only going to see the high frequency components. Oh, sorry. Low frequency components you are going to see, high frequency component you are filtering out. Okay, sorry. What is high frequency component? That is appearing more number of times. 0 is appearing more number of times. There is a high frequency. You have removed that and you have seen that there is 1. So what is the size of this filter has a very important role in that. If the filter size is bigger, you are going to see the bigger items. If your filter size is smaller, you are going to focus on that thing. So in an image, if you want to catch a small item, so the size of filter should be of that particular size only. Okay. So this is one important thing that I wanted to tell to you. If you want to see this much size 1, so filter size would also be of the same order. Okay. Next thing that I wanted to tell you that just think that given an image, I am going to get something output, and this output is created because I have a filter or kernel. If I increase this kernel to full, means I am having more connections, I am having more information. So that would be better than this smaller one, na? Yes or no? What I am telling that I am applying a filter of this size. So if I increase the filter size, more connection would be there, better feature would be there. Am I right? Correct.
The recording of the session is
Okay. Good. So what I was telling that this is the size of filter, which is 3 by 3. If I increase the size, looks like that I have more parameters. Looks like that I will be getting more things. Is it better to have more things? Looks like that it is better. But we are using smaller one. Why we are using smaller one? This is again a very interesting thing to know. Actually, what happens that is this thing we call as a sparse connectivity. Okay. By having the CNN, what is going to happen that you can think that if you have an image, first row, then second row, then third row, if you cut out those values and put one by one, you are going to get a, from this 2 cross 2, you are going to get all these values side by side. On this you are actually applying a filter. Filter would be applied if it is filter 2 cross 2 filter is applied on these 4 values. You can think that it is connected to only these 4 values. Then the next value is coming from these 4 things. So you can safely assume that there is these are again a neural network, neurons which are connected with a very few items, not with all. I wanted to say that if you connect all this, because this neuron was in this kind of setting, it is only connected to the 4. If I connect to the more neurons, it is going to be better. But this actually introduces more number of parameters, and it becomes very difficult to train. And this is the only reason that the people were not able to train beyond the 4 number of layers. So beyond 4 layers, people were not able to train because they were doing this mistake that they were actually combining everything with all the things. So this new deep learning arena introduces the CNN and tells that I would be connecting to only few, and their weights are shared. So number of weight is only 4. And I have also achieved something as a layer. So this is the advantage that this CNN is going to provide you. But what about the data? Because here we are having the loss of features. Essentially, what is going to happen that because I'm not telling that use only CNN at the first layer. Next layer also you can put the CNN, then again you can put the CNN layers, 16 layers, 8 layers you are going to put. Okay. So after 8 layer, what is going to happen that okay, this thing was only connected to this one, but this one is actually connected, somehow it is connected to all the things. When you go big above, so they are actually somehow connected to all the values that are inside. So at the end you are going to get complete understanding of the data with the lesser number of parameters. And because of this, you are getting good result despite having the sparse connectivity with respect to the neural network. So this is an important thing to know, that deep learning, in the deep learning arena, very important thing is that to have the neural networks, to have the CNNs, they have even having the lesser number of parameter, by introducing more number of layers, they can produce the similar kind of results. And as we rightly understood this, that the parameters are lesser because their parameters and weights are actually shared. Alright. One more thing, that sometimes what happens that if you have an image and you apply a filter, you are going to get an output. Sometimes this output can be made better if you just collect the best value, because the highest values are actually the things which are actually happening to the system. Okay, if you see in any of the block, the value that dominates is going to be more important in taking the decision. Okay, if some value is higher, its contribution to the decision is going to be higher as compared to the value which are actually lesser. So you can again apply some more technique, that is the max pooling, mean pooling and average pooling, that tells that out of these 4 values, out of every 4 values or 16 values or 9 values, you are going to pick the highest value and going to tell that. Okay, for example here, out of these 4 values, I am going to, if it is a max pooling, I am going to use only 8, one value, because out of these 5, 8, 7 and 6, 8 is the highest. So I can, from this I can reduce the feature size. Again, why I want to reduce the feature size? Because number of filters I am going to increase, so that different kind of features can be obtained, and then I can combine them into the better way. So there are 3 important concepts. One is pooling and another is a stride. What is a stride? The stride is that sometimes you want to here itself mix the thing. For example, out of these 4 values you got 12 value, then the next value can be obtained by putting the filter here or putting the filter here, or you take it more forward. So this is called a stride. So with the filter and stride, you can adjust to see that what is the best size for you, so that you will get the better result. Very important thing, that number of parameters, when the number of parameters are less, you have to do the lesser number of computations. So these are the small technical details that actually are there. Okay. Alright. So this is the paper I was talking about. 1997 I mentioned, 1998 paper, LINET. This architecture was given in 1998, and this takes a 32 cross 32 image, and that image contains a kind of digit. So you know that on postcard you write 1, 2, 3, 4 pin number. Somebody has cut this 1, 2, 3, 4 part and put it as a database. Okay, in one database, in this 32 cross 32 pixel, there is either 1, 2, any kind of number is written over there. I feed it to this network. So can you tell me what is that? Filter are 5, 1, 2, 3, 4, 5. You can see every filter creates one plane. So there are how many filters? 5 filters. Stride is 1, means for all values you are going to get that. And there is padding is 0, there is no padding, therefore the size reduces. And by this you get, from one image you get 6 images. Is it fine? Okay, how many parameters we have here? How many parameters we have? It is telling the filter size 3, 4, 5, 6 filters. Filter size it is telling 5 cross 5. So in 5 cross 5, how many values are there? 25. How many such filters are there? 6 filters. 25 into 6 is 150 different parameters. So 150 parameters are here. And what you get? 28 cross 28 cross 6. Okay. 28 cross 28 cross 6. Then it is going to apply 2 cross 2 filter. How many? 6 filters. 6 such filters. Every filter is going to generate how many? Every filter is generate one plane, 6 filters. So again you get the 6 values. 6 different things. Yes? Filter size is 2 cross 2. How many values it has? 2 cross 2 filter has how many values? 4. But it had to be applied on this because this deck has a 6 thing. Huh? So 2 cross through and how many are there? Huh? 6 planes are there. Huh? 2 cross 2 cross 6. So these very number of parameters. How many parameters are there? 2 cross 2 cross 6 cross 6. What is the value? It is 0 parameters because this is a pooling layer. Pooling layer means what? The values of whatever values are there, you are going to get what? One value. And maximum, because max pooling or min pooling, wherever pooling is written, understand it as a max pooling. So, does max require any parameter? It does not require any parameter because चाहे जितनी वैल्यूज मुझे दे दो, अगर मैक्सिमम है तो मुझे पता है क्या करना है. I would sort, find out the maximum. So there is no parameter as such. So number of parameters is 0. Then again there is a filter. This filter is convolution layer. On the convolution layer there is a filter which is size. This is the convolution layer 2. Filter size is 5 cross 5. How many parameters? 5 cross 5 cross 6. 5 cross 5 cross 6. And how many of them are there? 16. So 16 multiplied by 5 cross 5 cross 6. So 2400 parameters. Then again I am going to apply a pooling. So there is no parameter. So how many values I have now? Size keep reducing. It is 5 cross 5 cross 5 cross 5 cross 16. So how many values are there? You see, and then there is a fully connected layer. Fully connected layer are actually the classification heads. They give you the classification. So 120 neurons are here. Every neuron is going to be connected with all of them. How many are they? 5 cross 5 cross 16 multiplied by 120. So these many number of parameters are here. Okay. Sometimes one is also added to that because the bias term is also added over here. So this you see the calculation. What is that? Then there are next fully connected layer where 84 neurons are there. All of them would be connected because it's fully connected. All of them would be connected to the previous one. Every one is going to be connected to 120. So 120 multiplied by 84. Okay. So this is the number. And then last 10 are connected with 84. So it is 85 why? I told you that for every one there is one more connection which can be given to bias. So 81 is connected to 85. 84 are these plus one bias. 85 will multiplied by 10. So these many number of parameters. So by this you can estimate that how many parameters are there. And we have gone to this that how earlier gone to this particular slide earlier also that initially people were using histogram of gradient, LBP, linear binary pattern, etc. And their accuracies are very less, but deep learning has increased it very large. So what was the architecture? Architecture was this. This architecture is called LXNet. How many layers it has? I told you the 8 number of layers it has. Okay, let us see. Going in much detail with this is not that much required. That actually what is the value, that is not much important. We should understand the concept and how they are related with each other. Okay. So people actually think about this that initially you get the features, lesser number of features, but at the later point of time you do more mixing on the features. Okay. Initially you can see that he has applied a filter of 11 cross 11. Okay, how many filters? 96 filters. Then did the max pooling. So max pooling is not considered as a layer because it does not have parameters. So the first parameter layer, second, third, fourth, fifth, sixth, seventh, eight layer. Right? So after getting this, you apply max pooling so that lesser number of processing you need to do. Then you apply 256. Why? Because you want to do more mixing of the features. Then again do the max pooling. Again do the different kind of mixing. 384 mixing. Then again 384. Then 256. And then do your max pooling and then 4096. Then 4096. And then there is 1000. Why 1000?
1000 classes.
Because there were 1000 classes. 1000 classes in this database. Okay? So with respect to the every class, there is a neuron. If it says n, 1 means it is of that particular. So if multiple object can also be there in one image. Person having apple means apple and person both are there. So more than one neuron can tell one value.
Sir?
Okay. Yes.
So I have a question regarding the previous slide.
Next slide. Yeah.
So previous slide.
Previous.
Yeah.
Okay. This.
Okay. So the filter is like that small gray cube, right?
Here we have a filter. Yeah.
So that's the convolutional layers.
Correct.
And
this is the filter. Yeah. This is the
And
filter.
that size 28 into 28 is for the convolutional layer.
28, look 32 cross 32 I have, but if I apply a filter of size 5 cross 5, so my size becomes 28 cross 28. How? My size reduces. So, as
That's what I'm getting. Like
Correct.
the filter size is 5 cross 5.
correct.
So with one stride, if the stride value is 1, so we are taking like from 5 pixels we are taking one value, right?
One value, huh?
So that is how it becomes 28.
Correct.
So the filter is that small gray area, right?
Yes.
And in different layers, the filter is different filters.
In different layers, the filter values are different.
Like in convolutional
Correct.
layer 1,
Yes.
in
Yeah.
convolutional layer
With
1.
respect to this, filter values are different.
So the weight is associated with that filter, or the inside, like if there is like earlier you said na, in a filter, if we take value 1 0 minus 1, then 1 0 minus 1, then 1 0 minus 1. So weights are associated with that filter or with the value 1 0 minus 1, 1 0 minus 1.
Okay, 1 0 minus 1 is actually the weight.
It's a filter.
It's a weight. Filter has it. This is the weight.
Okay, so we update the value of the filters actually.
On the image there is some value.
Yes.
In our previous example, all the values were 150.
Yes.
So these are the image values.
Yes.
My filter has 1 0 minus 1, 1 0 minus 1, 1 0 minus 1. These are the weights. These values are weight. Okay? These values are weight.
So like
If I want to get filtered output of this image, I would multiply it with this, get one value. So out of these 9 values, I would be getting one value. Okay? But I can get second value, I can just shift it one pixel and then again 9 value, where 6 values would be already present in the previous one also. So with them, I can create one more value. So how many values I can create? I can start from here, but I cannot go till end. Before end, I would be stopping. Before 5 values, I would be stopping. So this actually says that filter size minus 1, I have to, the original size minus filter size plus 1. This is the size of the previous one, because you have to stop. First value you get the value, but the last you will be stopping over here. So filter size minus 1 values would not be available. F minus 1 values would not be available. So there is another.
Sir, actually, like when we imagine like that neuron diagram, right? Like there are 5 neurons in the input layer. Then in the hidden layer there are suppose 3 neurons.
Mm-hmm.
So like we make that circle diagram, right? So each of that, each of that neuron is kind of a filter, and weight is associated with that connections. So is that thing a different weight, and then filters value are different weights? So are those also combined?
Weight and filter values are same. Just I am telling this. Okay. Weights means the strength or values.
So there is no weight values with the connections.
That is the value. Because look, let me go to the previous one. You are here. Okay. Try to understand this one. Okay. This is a neuron. This neuron is not connected to everybody. Here. It is not connected to everybody. It is connected to with the only 4 one. And all of them are at a different place. If I would be putting any other place, this connection would be different. So you can assume that there is a weight. You can assume that there is a weight which is inside that particular table. Am I able to tell you?
Yes, sir. So sir, basically, one of these filter will decide that what class this image is from, or combined.
Look, this is actually not going to give you say one output, na? Because this is going to give you output, multiple output you will be getting. If you set one thing, multiple outputs you will be getting. For every pixel you are not telling that, na? So the output, the final output you will be getting after applying this fully connected one. So this part that you are talking about is only here. But final output, to get the final output, what is the class, you have to put a fully connected head classification head here. So the output that what this item, what class this item belongs to, for that you have to put a fully connected at the end. Am I able to tell you? Filters have this. My filters here you can see that K is equal to kernel size. Kernel size is how many kernels? 6 kernels are applied. Filter size is 5 cross 5. 25 values are there. Those values are going to be applied at different places. I am going to get another feature one. Second one because 6 we have. First could be blurring, second could be the edge enhancement, third could be edge extraction, something else. Different kind of things are possible. So, alright. Okay. Okay. So now we were here, we were seeing what is LXNet. So as I told you that LXNet has 8 number of layers, and we are going to only count those places where there is a parameter. Max pooling does not have any parameter because we know that only out of few values I am going to take the max pooling. Why we do max pooling? 2 reasons. Whatever is important I am going to collect and reduce the number of processing. Okay. And this is what the structure is. So need not to go into much detail. More than this, you should understand only this part, that initially 96, then 256, then 256, then 384. I am going to increase, because I want to do more mixing of the features, developed features. At the end, there is fully connected. As I told you that the next person came, that is a ZFNet, that told that instead of using 11 cross 11 here, if you put 7 cross 7, you will be using the lesser number of parameters and your accuracy can increase. So he had proposed a different architecture where there is a difference in the total number of parameters. A lot more parameters are here also. So 1.45 million parameters are lesser in the LXNet, and ZFNet has more parameters. Okay, this is LXNet, this is ZFNet. Any special observation? Again, you can see that 96, 256, 512, 1024, 512, and then 4096, 4096. Okay? All right. Any question? Okay. So at the end, what happens now? At the end, what happens that if you increase the things over here, so this number of parameters here increases too much. So that's why at the final layer, sometimes you want to do a consolidation so that you save the number of parameters over here. Because यहाँ पे जितना बड़ा होगा, everything is going to be connected with everything. So that's why it is something like that. Okay, next architecture was we thought about that instead of using 8, use 16 or 19. This is the other architecture, VGG 16, that actually has 16 layers. Can we see 16 layers? 16 layers. So places where there is a parameter 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay? Nothing fancy. Only thing is this, that that they have always used the kernel size to be 3x3, because now they are having more deeper architecture. So as I told you that two things, if 3x3, above 3x3 you again put 3x3, so first one looks like 9x9. It already become very bigger. So this is the architecture. Nothing fancy on that. ICLR 2015 paper. I think it's very intuitive, na? Very simple. Next architecture, inception rate. That tells that you see the things at different sizes. So what it does, that it applies different size filters. Few minutes back I told you that if you put the bigger filter, you are actually seeing the bigger thing. Smaller filters seeing the smaller things. Different kind of filters, 5x5, 3x3, 1x1, different kind of filters and max pooling. You combine all these things, put at one place, and then take it forward. Okay? This is called the inception block. However, this is one part only. It actually one more things. It also introduces one thing that is called the 1x1 convolution. Because when you are putting multiple things at one place, what happens that this depth becomes very high. Number of parameters, if number of filters you increase, this increases. Okay, this increases. So more processing is required at a later point of time, because he had to do a computation with all of these items. So this architecture also introduces something called 1x1 convolution. It says that I am going to find out the linear combination of all these items and put it here. So 1x1, this is the 1x1 convolution that actually here into the previous slide was actually mentioned. So here 1x1 was written, na? 1x1. This 1x1 does what? That this is a big thing, D is a big thing. It try to reduce it so that the number of processing is actually less number of processing is required. Okay. So this is one inception block, and it has 1x1 convolution, 3x3 max pooling. Then after 3x3 max pooling, 1x1 convolution, 5x5, 3x3, and then concatenate all these values and take it forward. So nothing more than this is required. Just try to understand this part, that having this kind of architecture is actually introduces a lot more parameter. There was in the previous architecture, we have always seen that at the end there were two 4096 things. So this 4096 into 4096, in between lot of connections were there. Just see that 4096 multiplied by 4096, how many zeros are there? So 3 zeros, 6 zeros, and 7 zeros. So those many 1 into 7 zero number of parameters are there inside. So he has reduced those parameters, so removed one of them and taken all the processing inside. Okay, all the processing inside, because number of parameters he has increased in a huge number inside. You can see that 64, then 192, then 256, then 480, then inception blocks 512, 528, 832, 1024, and then average pooling, then dropout. Again, he is introducing something more important, that is dropout also. 40% of the values he has dropped out, and then used 1000, then after again 1000. So this number of parameters, there earlier 4000 parameters were there, 4000 parameters there. So from from the classification heads he had introduced the parameter inside and definitely got the better result. So this is what the Google did. Does it make sense? तो अगर आप देखेंगे if you see from the very high level perspective, तो जैसे मैंने कहा ना कि सिर्फ किसी भी चीज़ को देखिए तो अलग अलग साइज से देखिए, उसके अलावा भी बहुत चीज़ें करनी पड़ेंगी, क्योंकि नंबर ऑफ पैरामीटर उससे आप बढ़ा लेंगे फिर आप कंप्यूट नहीं कर पाएंगे, यू नॉट बी एबल टू कंप्यूट. टू सॉल्व दैट इशू व्हाट अदर चेंजेस नीड टू बी डन? नंबर 1, 4000 become 1000, one layer has been removed, and even here when the values were there 40% values are actually dropped out. Okay, drop out बड़ा विचित्र मामला है. ड्रॉप आउट किसको पता है क्या है? ड्रॉप आउट जो है बहुत जरूरी चीज़ है कि उसमें क्या है कि जैसे हमारा जो वैल्यू है उसमें हमें बेस्ट वैल्यू चाहिए. मान लो 10 वैल्यू है आपको और 10 वैल्यू में आपको बेस्ट चाहिए, बट आई एम टेलिंग यूज ओनली 9, रैंडमली एक वैल्यू में मिस कर देता. मोस्ट ऑफ द टाइम आपको बेस्ट मिलेगा, कभी कभी नहीं भी मिलेगा. उसका फ़ायदा क्या होगा? उससे बहुत डिफरेंट काइंड ऑफ फायदा मिलता है ना, डिफरेंट काइंड ऑफ फायदा मिलता है. आपने वो जैसे जेनेटिक्स में लोगों ने पढ़ा होगा कि म्यूटेशन एक चीज़ होता है ना, बीच में अचानक किसी एक चीज़ को हम फ्लिप कर देते हैं, जिससे कारण वो खराब भी हो सकता है लेकिन अच्छा भी हो सकता है, और जब वो अच्छा हो जाता है तो बहुत फायदा करता है ना. तो इस तरीके की चीज़ है ये कि ड्रॉप आउट जो है रेगुलराइजर है, जो कि सिस्टम को दैट एक्चुअली हेल्प्स अस टू मेक द सिस्टम बेटर फॉर द नॉन सीड आइटम्स. Okay, because for the same item we have measured something bad. All right. So what was the next architecture? Very important feature. 12 times less connection as compared to HelixNet. HelixNet से भी कम connections है इसके पास. 2 times more computation as compared to HelixNet. It does more computation with very high accuracy. Okay, this is what the parameter is. Next thing was ResNet. And ResNet was, याद है कितने थे उसमें? 150. कहाँ आदमी लोग बात कर रहे हैं 8-16, ये टॉकिंग अबाउट 152 more layers. तो उसका आइडिया बड़ा सिंपल है. उसने कहा देखो ऐसा है कि अगर if something happens in 5 layers and if I apply 6 layers, okay, that's just linear क्या कहना हो, something can be developed using 5 layers. I apply 6 layers. Whether the network would be work perfectly or not, because I know that I believe on the network कि network can be trained. अगर network train हो सकता है तो 5 वाले को train हो जाएगा, next वाले को 1 कर लेगा, है ना. वो सारी value 1 कर लेगा. They are just passed away because I believe that network can be trained using back propagation. Network can be trained. If the network can be trained, so network would train 5 layers and next layer would be 1. If I apply 7 layers, same thing. So for any problem, if I don't know that how many layers I should apply 100 layers. मुझे पता है यार 100 तो बहुत easy, 100 is a very large number. Definitely my work would be done. 100 is a very large number. My work would be done. This is what the concept is. It says that if something can be done with these number of layers, if I increase few layers, so they would definitely only pass these values to the next layer and my task would be done. And I believe the network can be trained. आनी बात समझ में? ये इतना सिंपल कॉन्सेप्ट है. ResNet इसलिए 150 लेयर 150 लेयर लगा देता है और उसके बाद ट्रेनिंग स्टार्ट करता है. कहानी उसके बाद शुरू होती है. कहानी इसके बाद शुरू होती है. क्या है भाई ये एरर रेट है ना, उधर की तरफ एरर रेट है, इधर की तरफ इटरेशंस है. और when we have 20 layers, this is the error rate. Okay, when we increase it 32 layers, what we are expecting? ज़्यादा लेयर बढ़ाने पे क्या होता है? इस पे रहेगा या उससे कम करेगा? यही तो करे, बट ये तो ज़्यादा एरर दे रहा है. 44 लेयर किया और ज़्यादा, 56 किया और ज्यादा टेढ़ा मामला हो गया। समझ रहे हो? दिस ग्राफ आप देख रहे हो, जबकि होना नहीं चाहिए ऐसा। What I told you, if something can be done with 5 layers, if I apply 6 layer, I believe on the back propagation. सब लोग believe करते भाई। So if everybody believes on this technique, so this should work. So this should be at least at the same level. It cannot go up, but it is going up. कुछ तो प्रॉब्लम हुआ। अब वो प्रॉब्लम क्या हुआ? प्रॉब्लम ये हुआ कि बैक प्रोपोगेशन ट्रेन कैसे करता है, सोचना पड़ेगा हमें पर। बैक प्रोपोगेशन किसी चीज को ट्रेन कैसे करता है? हाउ बैक प्रोपोगेशन वर्क्स? बैक प्रोपोगेशन ट्राइज टू फाइंड आउट ए ग्रेडियंट कि एट दिस लेवल व्हाट इज द ग्रेडियंट, एंड इट गोज against the gradient so that I will either, because gradient tells you what is the direction, if you go in that direction the value is going to increase, you go to the negative direction of that thing so that your error reduces. It does in that way. Means if this value is working, nearby value should also work. Okay, it believes in a concept, it believes that if some value is working, nearby value should also work. Sometimes they are better or wrong, but I would be go to the better direction because I know that what is the gradient. I would go to the better direction so that I would be better. This is the underlying assumption of the back propagation. But in our case, what we decided few minutes back, if something works on the 5 layer, if I put the 6th layer, it passes the value. Passes the value means 1. If instead of 1 I put 0.9, will it be working? गड़बड़ हो जाएगा। If 5 layer network that is working, if I am going to put another layer and वहाँ पे जो connection है उसमें 1 के अलावा 0.9 आ जाए या 1.1 आ जाए, चलेगा वो? नहीं चलेगा। आप समझ पा रहे हैं मेरी बात? तो जो the fundamental requirement of that back propagation has an issue. That's why it is happening. After increasing, क्या कहना चाहता हूँ मैं? After increasing the number of layers, things are not that straightforward. They have error, they have problems. If I increase the straight away, increase the number of layers, things are not going to work. Earlier हमको लगा था करेगा, अब क्या करूँ मैं तो फंस गया। नंबर ऑफ लेयर इंक्रीज नहीं कर सकते। आइडिया हमारा वही था, हमने यही आने रखा था ना। अब देखिए यहाँ पे इनोवेशन आता है। This is why the paper is important. This is why the paper is important. आपने जो थोड़ी देर पहले मैं आपसे जब वो पूरे प्रोग्रेशन को डिस्कस कर रहा था, आपने कहा कि हाँ सर नेटवर्क का लेयर बढ़ा देंगे, एक्यूरेसी बढ़ जाएगी, उसने करके दिखा भी दिया। अब आप देख रहे हो कि अब आपने एक्सपेरिमेंट उसका डाला, एक्सपेरिमेंट में आप देख रहे हो कि गड़बड़ हो रहा है, आप फंस गए। आपको लगता है कि आपका कॉन्सेप्ट ही गलत था। अभी तो यही लगा ना, कॉन्सेप्ट गलत नहीं था, उसमें कुछ और करना पड़ेगा जिससे कि वो कॉन्सेप्ट चले। यहाँ पे आती है ना कि आप क्या करते हो, आप कैसे फिर से वही चीज कर लेते हो कि आप कैसे फिर से वही चीज अचीव कर पाते हो। हाउ यू व्हाट यू आर गोइंग टू डू सो दैट यू कैन अचीव द सेम काइंड ऑफ थिंग्स वंस अगेन। व्हाट इंस्टेड ऑफ 1 कैन आई यूज एनी अदर वैल्यू इन द 6th लेयर? ये तो रिक्वायरमेंट है। हाउ कैन आई डू दैट? आई कैन डू दैट बाय इंट्रोड्यूसिंग समथिंग दैट इज कॉल्ड द skip connection. Here I want the specific value 1, but if I connect the previous layer with this layer, then if this is not 1, then something can come from here and that can make it 1, because other layer is learning, it can change its parameter, so the summation becomes 1. My value is not 1, but because of the skip connection, some value that is coming from the previous layer, it can provide me some value so that my summation becomes 1. And here the nearby values would be working because he can change the value. Nearby things are working. So this is very important thing, that it introduces something called skip connection. What? Skip connection. ये उसका सबसे important बात है। उसने पेपर ने ऐसे किया. Now he has proposed that this architecture that I was thinking, instead of this, I am going to have the skip connections. Okay, I am going to have the skip connections. Correct? And by this, the network was able to be trained. Okay? The 152 layers deep neural network of ResNet was better than the human. and it has a error of 3.6%. It is better than the second best system on image detection. You can see that. So second best से वो 16% अच्छा था. जो second best network था उससे 16% अच्छा है. और if you consider the localization thing, it is where the item is 27% on the COCO database, and on the segmentation it is 12% better. So this is what I wanted to tell you, that this is what the result is. Okay, got the idea? Okay. There are specific hyperparameters that if you say your initialization, SDD, and so many things, so that is not important. Next task, one more architecture that I wanted to see about that. This is a problem where this is a high definition image taken from the microscope, and we wanted to tell that these are the one item, the second item, or where are the boundaries. This task is called the segmentation. So ISBI challenge, there was a challenge open, and as I mentioned, that electron microscope slides were there, and the person had to do this particular task. So this was the architecture proposed. This architecture is called UNIT. Very interesting kind of architecture. Let me just tell you that what this architecture. It looks like U, but essentially inside things are connected. What is the important of this architecture is this: whatever size is input, similar size is going to be given as an output. Okay. There are 2-3 operations that image actually cropped. It is taken smaller and then applied 2 kind of filter, then again cropped, again applied 2 kind of filters, and this kind of, you can say that there is a convolution operator of 3 cross 3, and so convolution of 3 cross 3, then convolution of 3 cross 3. Then this operation is copy and crop. This part is cropped and sent over here. This is the max pooling of 2 cross 2, therefore the size actually reduces. Again here the size reduces, here size reduces. Then 3 cross 3, 3 cross 3, 3 cross 3, and by this you are going to get what? Segmentation. अब आप कहेंगे कि सर इससे segmentation कैसे हो जाता है? How you get the segmentation? So answer is, I believe on back propagation. I believe on back propagation, and in the process I have done something so that I get the very small size 1024 size representation of the same image, from which I can reconstruct everything. So from the big image, if you extracted something and that can generate the similar kind of thing, means what very important thing has actually you have actually extracted, and then if you propagate the same thing, so 1024, why 1024? Because it's a very multiple of 2. So it is again going to give you the output, and again you can propagate and find out that what is the corresponding pixels and things. So very high accuracy, and this architecture has achieved the IOU, means how much overlapping the actual and the prediction is 77% as compared to the 46% of the second one. So other people were able to do only 46%, and this model was able to do 77%. 15 people. Okay, very phenomenal paper. And then comes this very interesting paper. I think everybody must have heard about this. You only look once. Okay. So YOLO is an interesting problem. YOLO solves a very interesting problem, that in an image, where is the object? Okay, object has classes. This is the dog, this is cycle, and this is truck. So how to do that? Object detection. Any idea? How can we do that object detection? If a big image is given and I want to do the object detection, so the method should be that a big image is given to me. I will divide the image into equal parts. For every part I would see that is there a cat, is there a cat, is there a cat, is there a cat. The places where I see one, so those things I can just match. I can tell that here is a cat. Okay. But the question comes, what should be the size of this block? Okay. What should be the stride? All these things are very difficult to decide, because if total number of possibilities I see, they are nearly infinite. So there was a very interesting lineup of solutions that came, okay, at that time before that. And those solutions, earlier people were actually using deformative part modeling. They think that if, for example, if there is a cat, so cat, if there is a person has a hand, person has a head, person has a body, leg, so they can be deformed. Just try to see that is there a hand, is there a leg, is there a head, and they can be combined in a very different way. And if you can combine them and make something like human, then you say that it is a human. So this kind of model has an accuracy of how much? There is a specific database, a Pascal database, that is called 33.7% accuracy. Next year, a model came that is called the regional CNN, RCNN, and this says that I am going to divide the things into region. For those regions, I am going to find out the features, and then I apply the classifier. Accuracy was 66%. Jabardast model हुआ. Then comes the fast RCNN. It says that features, it combines features and does the things on the feature also. So the accuracy increased to 70%. Then faster RCNN. It again applies some kind of changes. Okay. Faster RCNN has two kind of architecture, using a backbone as a BGG, backbone as a ZFnet. They have accuracy 62% and 73%. So these results are produced by the same group. When they come up with RCNN, it was a big hit into the research community. That the things which has the accuracy of 33%, now we have accuracy of 66%. Then they increased this 66% to next year to 70%, and after that they increased it to 73%. Okay, forget about this. This just tells that if instead of VGG I use JavaScript, what is the accuracy? But they are becoming faster also. So 7 frames per second they can process. Then comes the Euro. Euro is very simple architecture. It says that you don't get the thing complex. If you have big thing, okay, to divide this into 7 cross 7. 7 cross 7 means 49 different things. So earlier what you were doing, that you were applying detector here, here, here. How many times you have to apply the detector? For every block you have to apply the detector. No? 49 times you have to apply. But if I say that inside image you put 49 detector itself, given the image, after that you apply 49 detector itself inside. So within 1 unit of time you will be able to get all the results. This is the important thing. That it applies 49 different parallel detectors at the same time. So by this you get this kind of output. It looks like that there is a dog. So if you know that there is a dog, then and there are a few more things that I just don't want to cover in the interest of don't confusing you. That if there is a dog, I can just find out the bounding box. I can tell that dog is here. Okay. Here the cycle is, so I can find out. I can tell the cycle is inside this particular region. If there is car, I can say that the car is inside this region. So it is fast. Why it is fast? Again, is it any magic? No. I have divided the image into equal parts. For every part I have applied so many parallel things. That's why I am fast. So this YOLO has 45 frames per second processing power. So that's why it is nearly real time. And accuracy is little bit lesser because it is more correct but less accurate, but it is fine. Sometimes it is fine. We also do some kind of error, it is fine. Latest is YOLO V9 and it is very fast. You can by yourself run and see that how the things is happening. Okay. So I think I am done with this. So I have tried to cover some of the important architectures that actually deploy the CNNs and do the object detection, do the feature extraction, do the classification kind of thing. Any questions if you have? I think I have taken 45 minutes of Raj, but you will forgive me. Any questions? Yeah. Like online participant, do you have any question?
So why the value
Why? Yeah.
all your friends jumps to a value future?
Yes, he will also jump because statistically it is happening, na? All the friends are jumping, so he will also jump. Okay. So this is what the statistics is really. Okay. So it is just a joke. Yeah. Anything else? Well, everybody is jumping, so you would also jump. You don't think everybody is good or bad. So data happens like this. Okay. Data happens like this. And behind everything, there is only one thing prevails, that is statistics. Okay, if statistics says it is happening, then it is happening. Okay. All right. Thank you very much for being wonderful audience. Thank you, everybody. Thank you. I think the next session would be in your lab.